Welcome to all of you. In this session, we'll go through the division operation. The statement: write an ALP to perform division operation on 8-bit number by 8-bit number. So that means the procedure is 8-bit divided by 8-bit is what we are going to perform. Let us first go to the division instruction. So it is of the format div AB, meaning divide A by B. Store the integer part of the quotient in register A and the integer part of the remainder in register B. So that means after performing the division operation, the initial value that was stored will be updated by the quotient and the remainder sequentially in register A and the register B. So with respect to this program, I am going to have certain considerations. The two values that we need will be stored in the memory location, that is the two 8-bit numbers are stored in two memory locations 30H and 31H. Then after performing the division operation, the result I am going to store that in two memory locations, that is after division contents of A is stored to the memory location 32H and the B, that's the remainder, will be stored to the memory location 33H. These two are my considerations. If you want, you can change the memory location, or if you want, you can show the solution in any of the registers also. Let us get into the program. So we need to get the data from the memory location as per our considerations. So for that I am loading the R0, which is the memory pointer, with the value 30H. Move R0 comma hash 30H. I am fetching my first value from the memory pointed by R0 to register A. So move A comma at R0. Then second value I need to fetch. Therefore I am incrementing the R0 so that it can point to the memory location 31H. So increment R0. Now the R0 will become 31H. The R0 contains the value 31H. Fetch the value from the memory location pointed by R0, that is move B comma at R0. Now B holds the second value. Perform the division operation. So it is A divided by B we are going to have. So after division, A holds the quotient integer value, B holds the remainder integer value. We need to store these two values, the quotient and the remainder, to the memory location. Therefore, I am again incrementing R0. Now R0 will be pointing to memory location 32H. Store the quotient to the memory pointed by R0. So move at R0 comma A. Then I need to store the remainder to 33H. Therefore increment R0. After incrementing, R0 is now pointing to the memory location 33H. Store the contents of B to that memory location, that is move at R0 comma B. So after completion, so both in register A and B we can have the quotient and the remainder sequentially, and also the result is also available in the memory location 32H and 33H also. Now let us go through the simulation of it. So first we need to have the data in the memory location. So I have just initialized it to the memory location 30H. Now let us load some values to this one. So I will be loading to the first location 05H and another value I am loading it as 02H. So final division operation is 05 divided by 02, so that we can illustrate both quotient as well as the remainder. The values has been loaded to the memory location. So now R0 is the memory pointer. So we need to initialize R0 with this memory location, that is 30H. So starting with the execution, R0 will be first loaded with 30H. Now the value stored in 30H will be fetched to the register A after the execution of this instruction. Now A is loaded with value 05H, that is there in the memory. We need to fetch the next value from the memory. Therefore increment the R0. At present it is 30. We need to make it 31. So now R0 has become 31. Fetch the second value stored in the memory location to register B. So now the register B contains 0 to H. Now dive instruction performs A divided by B operation. So after that the initial values that we are observing that will be vanished and the updated result will be stored in register A and B. Now we can observe that. So now A consists of the value 2, that is the quotient value, and B consists of the value 1, that is the remainder value. Now I am going to store this to the memory location 32H and 33H. So therefore I am first incrementing the register R0. Now it is the register R0, now it is 32H. For that I am storing the quotient value. So the quotient has been stored over here. Then the remainder value will be stored to the next memory location. Therefore increment R0 again and store the contents of B to the memory location. Now the next memory location holds the value 1. So 02 is the quotient, 01 is the remainder over here. Now end the execution. Thanks for joining.